Welcome to another video. This one is going to be about hypothesis testing proportions. Now for this video, you're again going to want this handout, which is the work through of doing any hypothesis test. You are going to want the z-score table. And why is it a z-score? Because all proportions are going to deal with z-scores, and all of the total n values you're going to be given are over 30, which also implies using a z-score. And you're also going to want this hypothesis testing flowchart for the conclusions. So let's get going. Also, I am using the examples PDF. I did update this, so if you already had it printed out, go back and double check all of the questions because I changed a little bit on a couple numbers. So it says we have 46% of people believe that there is life on other planets in the universe. A scientist does not agree with this finding. He surveyed 120 randomly selected individuals and found 48 believe that there is life on other planets. At alpha equaling 0.010, is there sufficient evidence to conclude that the percentage differs from 46? So same thing as with any and all hypothesis tests. You'll write down your hypotheses, which will be your null, and also your alternate. Then after that, we will want the critical values, then test statistic, and then I'll leave some space where we will then write the decision and conclusion. Now for the hypotheses. What hypotheses are you actually testing? It says, is there sufficient evidence to conclude that the percentage differs from 46? And this keyword differs. That means it's different from 46 and referring to 46%. So there I have my claim. My claim being the proportion is not equal to 0.46. Which means for the null hypotheses, it would equal 0.46. The alternate always tells you the tail test. Not equal would refer to having two tails. For two tails, I will take alpha, divide it by 2, and that gives you 0.005 to go inside of each tail. Now only one of these sides I would like to see the double arrow, because it's going to be the same for the other side. And if I have 0.005 in the tail, then I would have 0.495 left over, which is what you need to look up on the table. So I need to find 0.495. So 0.495 is going to be right between these two, and it has an asterisk. So scroll down. 0.495 is 2.575. It's one of those two special z-scores because it's exactly halfway between two values. So I have positive, negative because this is two tail, and it would be 2.575, and I'll put those numbers on my picture. Now to find the test statistic. I know it's z because I just used the z table. The formula, since this is proportions and I have p, it would be this letter C. So z equals p hat minus p all over the square root of the quantity pq divided by n. So I'll write down the formula, which shows I know which formula I'm supposed to use. And now I can start plugging in. Now p hat is my sample proportion. My sample proportion here was 48 out of 120. If you want to simplify that, that's cool. That's fine. You're going to be plugging all this into a calculator at once, so it does not matter. P would be 0.46. So 0.46 again. Q is the complement of that. So how much would you have to add to 0.46 in order to equal 1? That would be 0.54. And this is all out of your original total, which is 120. This is going to give you z equaling negative 1.32. Now I'll put that on my picture, which would be to the right of the critical value negative 2.575 somewhere. And now for my decision. Where did that test statistic land? It landed outside of a tail, which means I'm going to be accepting the null hypotheses. Now for the conclusion, look at the flowchart. Did we start off with our claim containing equality? No. Not equal to does not mean equality. Do we reject the null hypotheses? Fail to reject is the same thing as accepting, so the very bottom conclusion would be the beginning. Which is the following: that there is not, or there isn't, sufficient sample evidence to support the claim that now you have to be careful how you would write this, because you can't say claim that the percentage differs from 46, because then there are a lot of details left out, and who would ever read this conclusion has no idea to what this refers. The way I wrote it was to claim that any value besides 46% of people believe that there is life on other planets in the universe. Okay, so next one. Researchers suspect that 18% of all high school students smoke at least one pack of cigarettes a day. At a randomly selected high school, out of a sample of 300 students, it was found that 50 smoked at least one pack of cigarettes a day. at alpha equaling 0.05, test the claim that less than 18% of all high school students smoke at least one pack of cigarettes a day. So hypotheses. And how do I know this is going to be a P? Because it's given me a percent for the claim to be tested. That's how I know this is a test of proportions. Now, if it just said an average, then it would be either a regular t-test or z-test for a mean. Now, the claim of which I am to test was they claimed that less than 18%. So that's going to be alternate, 0.18, which means the null will be greater than or equal to 0.18, and put that is my claim. The alternate, that is. Less than means a left tail test. Alpha is 0.05, which means the leftover would be 0.425, which I would have to look up on the table, the Z table. So I need to find the value closest to 0.45, and it happens to be the other special Z-score, which is 1.645, and it would be negative here. Then I have the test statistic. So Z is equal to P hat minus P, all on top of PQ over N square rooted. P hat is my sample proportion. So I'm looking to see how many out of how many. It said 50 out of 300. That can easily be simplified to 5 out of 30. 5 out of 30 can easily be simplified then to 1 out of 6. Minus 0.18. The complement of 0.18 to get 1 would be 0.82. N is the total amount for this test, which is 300. Remember, even if you simplify this, N is always going to be your total amount. So plug all of that into a calculator at once and round appropriately, which means to the second decimal place, and Z equals negative 0.60, which would be somewhere about here. Now I have a decision and conclusion. So, is my test statistic inside the tail or outside of the tail? It is outside of the tail, which means accept the null hypotheses. Then the conclusion. Did my original claim contain the condition of equality? No, it did not. Do you reject null hypotheses? No, you do not. So again, I'm in the very bottom start for my conclusion. Which is there is not or isn't sufficient sample evidence to support the claim. And let me go back to see what I should put for this. I can actually use the entire last part of this sentence, the claim that less than 18% of all high school students smoke at least one pack of cigarettes a day. Yes, this is very, very almost repetitive and similar to the hypothesis testing for a mean when n is more than 30. Truly, I believe the only difference here is knowing that you have a proportion, so your hypothesis has p instead of mu, and then your formula is just a little bit different for the test statistic. Okay, so nationally, at least 60% of PhD students have paid assistantships. A college dean feels that this is not true in his state, so he randomly selects 50 PhD students and finds that 24 have assistantships. At alpha equaling 0.05, is this dean correct? I am given a percent, so I know this is going to be P. And what claim are you to test here? Well, the dean feels that it is not true of at least 60% in his state. So he would be claiming that it's less than 60%. Which means I will have a left tail test. Alpha is 0.05. Left over there would be 0.45, which again gives you negative 1.645, like the previous. So put the formulas so that way it's known. I'm aware of which formula I'm supposed to use. Now p hat is my sample proportion, which in this case would be 24 out of 50. I know that 24 and 50 I can divide by 2, so that would give me 12 out of 25. Minus 0.60 or even just 0.6 is okay. Then I would have 0.6 times 0.4, all divided by my original amount, which is 50, square rooted. Put all of this into a calculator, and you should end up with negative 1.73. Put that on my picture. It's just inside of the tail, because the cutoff is negative 1.645. And negative 1.7 would be just a little more to the left. So it's close. So that decision would mean reject the null hypotheses. Now, did we start off with the condition of equality? No, we did not. Do we reject the null hypotheses? Yes, straight across. So the sample data support the claim. And what was this claim? The claim was that the proportion is less than 60%. Now, the proportion of what? That less than 60% of PhD students have paid assistantships. That's all I have for this video. I'll see you in the next one.